The astronaut who steps off the spacecraft on Mars will not be the same person who boarded it on Earth. Their bones will be more brittle, their heart will be smaller, their blood will be wrong. Their DNA will carry damage they cannot see. And if they ever try to come home, the planet that built them will refuse to take them back. This is not science fiction. It is the conclusion modern space medicine has quietly arrived at, and it is one of the most disturbing truths in human biology. The first people to set foot on Mars will not be coming home, not because we cannot build a return rocket, because their bodies will no longer fit on the planet that grew them. 3 days got us to the moon. Mars takes between 6 and 9 months in a single direction. A round trip plus surface stay totals a minimum of 2 to 3 years away from Earth. For 2 to 3 years, a human being lives under conditions no biological lineage has ever encountered. Mars sits, on average, 55 million kilometers from Earth. Light itself, the fastest thing in the universe, takes over 20 minutes to crawl that distance. 20 minutes out, 20 minutes back, 40 minutes minimum for a single radio exchange with mission control. An astronaut suffering a heart attack on a Mars mission will be dead long before Earth even knows there is a problem. There is no rescue. There is no hospital. There is nothing. That is the easy part of the journey. The hard part is what happens to your body. A Mars mission forces a human being through 3 completely different gravitational environments in sequence. First, weightlessness for the 6 to 9 month transit out. Then Mars surface gravity, only 38% of Earth's, for roughly 18 months on the ground. Then weightlessness again on the return. And finally, if the body even survives the trip back, full Earth gravity. Each of those transitions is a violent shock to a biological system that was tuned over 4 billion years of evolution for exactly one set of conditions. The body does not adapt, it decays, and it decays in ways that compound. The first decay is invisible. The space between Earth and Mars is bathed in cosmic radiation that our atmosphere normally absorbs before it touches a human cell. In transit, an astronaut absorbs between 800 and 1200 millisieverts of radiation across the full mission. That is roughly 700 times more than someone living a normal life on Earth. Translated into medical terms, it is the equivalent of more than 600 CT scans or 12,000 chest X-rays, all within 2 to 3 years. Every exposure damages DNA. Every damaged strand is a lottery ticket for cancer. The cumulative cancer risk increase is conservatively estimated at 5 to 10%. The cardiovascular system ages by decades. The brain shows measurable cognitive degradation, memory loss, slowed reaction times, difficulty making decisions. The lenses of the eyes begin clouding into early cataracts. Bone marrow is damaged, weakening the immune system from the inside out. Conventional shielding does not solve the problem. Thick metal shielding generates secondary radiation when high-energy particles slam into it, often making things worse than no shielding at all. There is no current technology capable of protecting a human across the full duration of a Mars mission. The astronaut absorbs the dose. The astronaut becomes a permanently altered organism. While radiation reworks the cells, gravity slowly rewrites the skeleton. Bone is not static. It is living tissue that constantly rebuilds itself based on the loads it carries. Every step you take signals to your skeleton that it is needed. Without those signals, the body stops investing in bone maintenance. It begins dismantling its own infrastructure. In zero gravity, astronauts lose between 1 and 3% of their bone mass every month. After half a year, the cumulative loss reaches as high as 18%. After a full year, more than a third of the skeleton has been dissolved. A Mars mission lasts at least 2. The worst-case projection puts bone loss above 50%. An elderly osteoporosis patient has typically lost between 30 and 40% of her skeletal density over an entire lifetime. A Mars astronaut in her 30s could exit the spacecraft with the bones of a frail 70-year-old. The bones that go first are the ones that matter most for life on Earth. The hips, the femurs, the spine, the very structures that hold a body upright against the pull of a planet. And the calcium leached from those disappearing bones has to go somewhere. It pours out through the kidneys and crystallizes along the way. Kidney stones become almost inevitable. Imagine passing one in deep space, 8 months from the nearest doctor. Muscles deteriorate at the same rate, 1 to 3% per month, dissolved by the body itself because it perceives no reason to maintain them. The leg muscles wither first, then the back, then the core. The fibers themselves shift composition, abandoning the slow endurance fibers that allow sustained activity and overpopulating with fast-twitch fibers that exhaust quickly. Cartilage in the joints thins. Tendons lose their elasticity. The mechanical scaffolding of the human body unbuilds itself, one cell at a time, all the way to Mars. The International Space Station gives us a preview. Crews on the ISS spend 2 hours of every single day strapped into resistance machines and weighted treadmills just to slow the damage. They cannot stop it. They can only delay it. After 6 months in orbit, many returning astronauts cannot walk unaided. Some require months of physical therapy. Some never recover the bone density they left with. And the ISS sits 400 kilometers above Earth, with rescue always available. A Mars mission lasts 6 times longer. There is no rescue. The most disturbing change happens inside the chest. Your heart is a muscle. On Earth, that muscle works hard every second of every day, pumping blood upward against gravity to feed your brain. In weightlessness, that work is no longer required. Blood floats freely. The heart, recognizing it is no longer being challenged, begins to shrink. Studies of long-duration ISS missions show heart mass losses of up to 20%. 20% of the most critical pump in the human body dismantled. The chambers weaken, the walls thin. Meanwhile, the blood itself behaves strangely. In zero gravity, it migrates upward, pooling in the head and chest. Astronauts on long missions develop visibly swollen faces, while their legs drain pale and thin. The body, sensing too much fluid in the upper half, excretes the excess, and total blood volume drops by as much as 20%. The cardiovascular system shrinks, weakens, and recalibrates itself for a world without weight. Now imagine standing up on Earth after 2 years of this. A shrunken heart, pumping reduced blood against full gravity, simply cannot. Blood pressure collapses the instant the astronaut rises. ISS returnees already faint after 6 months. Across a 2-year mission, the effect turns lethal. Even before the brittle bones snap and the wasted muscles give way, the heart will not push hard enough to keep the brain conscious. This is the trap nobody mentions when they sell the dream of Mars. The astronaut who reaches the Martian surface is no longer a creature of Earth. Bones thinned, muscles wasted, heart shrunk, DNA scarred, eyes clouding. They have become a different organism, built for a weaker world. Mars' gravity sustains them, but it is far too weak to rebuild what they lost. And so Earth, the only home our species has ever known, becomes a death trap. Returning would mean a gravitational load 3 times stronger than their body can survive, bones shattering at the slightest fall, a heart unable to reach the brain. The first attempt to stand would likely kill them. Solutions are being chased. Rotating spacecraft for artificial gravity, drugs to slow bone loss, faster engines. None are ready. The first people to walk on Mars will go, knowing the body that arrives is not the body that left, so they will stay. Not as visitors, but as permanent residents of another world, marooned by their own biology, watching a pale blue dot they can never touch again. Their children, born under Martian gravity, will be even less able to return. Within a single generation, the Earth-evolved body will be a memory. The horror is not that we cannot reach Mars. We can. The horror is what we leave behind to do it. Not the planet, the species,